So in this problem, we are given the value of tangent of theta over 2. That's square root of 1 minus e over 1 plus e times tangent of phi over 2. We need to show that cosine phi is given by this expression cosine theta minus e over 1 minus e times cosine theta. Let us begin. So here, what we'll do, we'll use the formula for cosine 2 phi. Cosine 2 phi, we can express in terms of the tangent function as 1 minus tangent squared phi divided by 1 plus tangent squared phi. Now what we'll do, we will divide this 2 pi with 2 such that 2 phi becomes phi. Now if we're dividing this angle 2 phi with 2, then we'll also have to divide the angle phi on the right hand side by 2 as well, such that our formula will become 1 minus tangent squared phi over 2 divided by 1 plus tangent squared phi over 2. Fine. So we'll proceed from here. Now we need to find out the value of tangent squared pi over 2. Here we are given here the expression in terms of tangent theta over 2. Let's use this. So we have tangent of theta over 2. So that's given by square root of 1 minus e over 1 plus e multiplied to tangent of phi over 2. Now, if we isolate tangent of phi over 2, so that becomes equals to the square root of 1 plus e over 1 minus e times tangent of theta over 2. We'll substitute this value here, such that we now have 1 minus, we get 1 plus e divided by 1 minus e multiplied to tangent squared theta over 2, whole divided by 1 plus, now squaring tangent squared phi over 2, that gives us 1 plus e over 1 minus e times tangent squared theta over 2. Okay, fine. Now what we'll do, we'll convert the tangent function to the equivalent ratio of sine and cosine. We get 1 minus 1 plus e over 1 minus e multiplied to sine squared theta over 2 over cosine squared theta over 2, whole divided by 1 added to 1 plus e over 1 minus e times sine squared theta over 2 divided by cosine squared theta over 2. We're going to simplify this by multiplying both numerator and the denominator with the 1 minus e times cosine squared theta over 2. That's going to give us 1 minus e times cosine squared theta over 2 minus 1 plus e added to sine squared theta over 2, whole divided by, we have 1 minus e times cosine squared theta over 2 added to 1 plus e multiplied to sine squared theta over 2. Okay, let's now further simplify. Now we get cosine squared theta over 2 minus e times cosine squared theta over 2 minus sine squared theta over 2 minus e cosine sine squared theta over 2 divided by cosine squared theta over 2 minus e multiplied to cosine squared theta over 2 plus sine squared theta over 2 plus e sine squared theta over 2. Fine. Now, we have cosine squared theta over 2 minus sine squared theta over 2. So this is going to be one single term, and then we're going to combine this second and the fourth term. We'll take negative e as the common factor. We have negative e multiplied to cosine squared theta over 2 plus sine squared theta over 2, whole divided by, we have cosine squared theta over 2 added to sine squared theta over 2. If we take negative e as the common factor, we can combine the second and the fourth term in the denominator to get cosine squared theta over 2 minus sine squared theta over 2. Now, cosine squared theta over 2 minus sine squared theta over 2, that's a standard formula. This will be cosine of 2 times theta over 2 minus e multiplied to, so cosine squared theta over 2 plus sine squared theta over 2 is identity with a value equals to 1 divided by, we have 1 minus e multiplied to cosine of 2 times theta over 2. So that finally gives us cosine theta minus e over 1 minus e cosine theta. So this is the value of cosine of phi. So let's verify. Finally, we obtain cosine of phi equals to cosine theta minus e over 1 minus e cosine theta.